Okay, let's talk about the idempotent matrix. What I have here is just what we had from the previous video, in which we got Q, matrix Q, which is the centering matrix. What I did is I took the identity matrix, just ones on the diagonals, and I also input a J matrix, just a 5 by 5 matrix of just ones. And then I defined Q with this formula that we used in the last video. So let's take another look at this. So remember, for Q we got our values of 4/5 on the diagonals and everything else was negative 1/5. Now with an idempotent matrix, if you remember, this is matrices with the property in that when you multiply it by itself it gives itself back. You would call that idempotent. And Q is an example of this. So we can say that centering matrices, or Q, are idempotent. And let's demonstrate this. So we can say, let's try S equals Q times Q. And let's look at that. Okay, as you notice, I didn't really put matrix define or matrix input, which you don't really need to, but I created S, which is Q times Q, and what it gave me was Q, in fact. And that's a demonstration that centering matrices are idempotent.